Consider a straight line problem which is inclined to both HP as well as VP. First of all, let us read out the problem. A straight line AB 80 mm long has its end A 10 mm above HP and 15 mm in front of VP. The front view and top views are 55 mm and 70 mm long respectively. Complete the projections and find the inclination to HP as well as VP. See, in this problem what is given is the straight line which is having the end A and B. The true length of the straight line is 80 mm and one end A is given 10 mm above HP and 15 mm in front of VP. So we can locate the first one end. Then the front view and top view lengths are given, that is front view length is 55 mm and top view length is 70 mm. So we have to complete the projection and find the inclination of this straight line with HP as well as VP. And then this is the problem which we can solve by minidrafter now. Okay. Let us try to solve the problem. First of all, we can construct an XY line centrally, and then we have to locate one end which is 10 mm above HP and 15 mm in front of VP. We can draw the perpendicular projector. Here I can mark one point at 10 mm and 15 mm below your XY line. So this point is called A dash, it is in the front view. This point is called your B, sorry, A. A dash, A, both are given. Now the top view length and front view lengths are given. The front view length is 55 mm. The front view inclination is not given. So let us assume that front view length is initially horizontal or parallel to XY line. That is 55 mm. So here I can mark one line for 55 mm. It is going to be your B dash. And then the top view I can mark through A, which is of 70 mm long. So this is your B. This A dash B dash has been obtained from the true length of the top view. So here this one we can just draw a perpendicular line downward, so that on this line the true length I can mark. Similarly, this top view is obtained from the true length inclination at the front view or in the VP. Now we can take the compass and then the true length which is given in the problem as 80 mm. We can mark this 80 mm or take this 80 mm in the compass or set the dimension in the compass, and then keeping this A dash here, and then I can mark one arc on the vertical line, and then from A as center I can mark this dimension on the vertical line drawn downwards. Now this is the point in the top view which is of 80 mm length. It is going to be your B1. This is the point, it is B1 dash. Now through these points I can draw a locus horizontally. On this line only your front view as well as top view is going to be there. Now I can take the radius which is equal to the front view of the straight line. I can just make an arc at the top view which is going to be your B dash. Similarly, I can set the dimensions in the top view, and then I can just draw an arc downward to cut the locus. So this is the point going to be your B. Now A and B dash I can join by a dark line. This is the front view and this one is the top view. Now A, B1 I can join by a light line to represent the true length. Similarly in the front view also, or in the VP plane, I can join this A dash and B1 dash. This is the inclinations of the straight line with respect to your HP as well as VP. Now I can measure this inclination by keeping this protractor, which is keeping this end coinciding here Here the true length is inclined at 30 degrees. Now it is going to be your 30 degrees. This inclination with respect to HP. But keeping this point coinciding, and then horizontal line, this point has to coincide with the A, and then the horizontal line 0 degree is to coincide with the horizontal line. So here this is 45 degrees. So the straight line is inclined at 30 degrees to HP and 45 degrees to VP. This is the complete projections. Of course, we have to mark the dimensions also. Here this A dash is at 10 mm. Here A is at 15 mm. This is 10 mm and this is 15 mm. This length is 55 mm. This top view length, front view length is 55 mm. This length is 70 mm. This is the complete projections we have drawn here. Thank you.